So today we're doing a projectile motion video and we're gonna need some help.
Hi, I'm Jeff and I want to play some football. Hi, I'm Bob and I want to have some fun.
Now before you ask how football and projectile motion relates, look here, see the arc? Both Jeff and Bob here are the same height at approximately 6'6", meaning we will not have to worry about added height in the equation. We can roughly estimate the gap in between them here is to 200 to 300 meters, which is no problem for those cannon arm of theirs. The airtime in between each throw has a 2-second average, and we know gravity's pull is about 10 meters per second squared. Now we want to calculate at what angle and what speed Bob must throw the ball in order to make it to Jeff. Knowing all this information, we can calculate the velocity of this in the horizontal and vertical directions to further analyze the throws. To clarify, velocity is the speed with a direction, while speed is just the measurement alone. We can first divide the 250 meter distance by the 2-second airtime to find the ball has a horizontal speed of 125 meters per second. The horizontal velocity of this ball is 125 meters per second east. Gravity's acceleration towards the Earth is about 10 meters per second squared, meaning that if the ball is only in the air for 2 seconds, then the initial vertical velocity has the same magnitude of gravity, but in opposite direction. With this, we can find the initial vertical velocity of the ball as 10 meters per second. We can now find the answer of what angle Bob must throw the ball and at what speed. Using the equation, angle equals arctangent of change in y over change in x, we will use the values of initial horizontal and initial vertical velocities as the change in y and x. This evaluates out to 4.6 degrees. Now to find out what speed Bob must throw the ball, we will use the Pythagorean theorem to find the hypotenuse of the triangle made by the horizontal and vertical velocities. This evaluates out to 125.4 meters per second, which gives us the solution that Bob must throw the ball at 125.4 meters per second at 4.6 degrees to make it to Jeff. We are now presented with a similar problem to the football one. This time, however, we must find the distance Bob jumped when jumping 60 degrees off the swing. To begin, we must calculate the speed of the swing. To calculate the speed of Bob, we must find the length of the arc he is swinging and the time it takes to travel across it. These two items of information will give us the speed Bob is traveling at. Now I've overlaid a circle which shows Bob's maximums on the swing and displayed the total angle of the circle he takes up, which is approximately 144 degrees. The length of the chain connecting the swing to the bar is 8 feet long. Combining these two pieces of information, we can use the formula for an arc, which is length equals angle times radius. The angle in this formula must be in radians, so 144 degrees in radians is 4 pi over 5 radians. This multiplied by the radius will give us the total swing length of 20.1 feet. This 20.1 feet is traveled in approximately 1.2 seconds, which gives us a speed of 16.8 feet per second. Now we have the speed of Bob before he jumps. The height Bob is at before the jump is 8 feet. With the information we have now, we can find the maximum distance that Bob jumps. First, we must find the horizontal and vertical velocities of Bob to calculate the maximum distance. Bob's vertical velocity can be found by using Bob's speed multiplied by the sine of the angle at which he jumps. This will leave us a vertical component of the speed. Bob's vertical velocity is 16.8 feet per second times the sine of 60, which is root 3 over 2, which will yield us the result of 14.4 feet per second. Next, we must find Bob's horizontal velocity. Bob's horizontal velocity will be found by multiplying the calculated speed by the cosine of 60, which is 1/2. By multiplying 16.6 by 1/2, we will find that Bob's horizontal velocity is 8.6 16.8 feet per second. Now, using the vertical velocity, we must find the total time Bob is in the air, which is the vertical velocity divided by the rate of gravity with the addition of the starting height. After converting gravity's force into feet, we will find that the total airtime is 1.2 seconds. Now with the airtime, we can find the distance Bob jumps by multiplying the airtime by Bob's calculated horizontal speed. 8.8 feet per second times 1.2 seconds will result in the distance of 10.56 feet. The solution to this problem is that at a speed of 16.8 feet per second and at the angle of 60 degrees, Bob can jump 10.56 feet.